Hello, and welcome to today's lesson. We're going to be covering topics under the Standard 4.2 in 8th grade, and also topics under the Study Island lesson, Similar Figures. So today we're going to be looking at what it means for a pair of shapes to be similar figures, and what that means is they're going to have the same shape, but they're going to be different sizes. So it's like you press the enlarge or reduce button on a copy machine. And as we're going through, please be taking notes. If I go too fast, you can pause and rewind and get caught back up, and that way you have something to study from and to look at when you're trying these problems on your own. And you can even pause at the beginning of a question, work the problem out yourself, and then watch the video to check yourself so you can get a gauge of what areas you still need to work on and practice and study, and what areas you're doing pretty well in and you just need to review. So I'm glad that you are joining us today, and let's go ahead and take some notes. So first, let's look closer at the definition of similar figures. So similar figures are figures or shapes that have the exact same shape but different sizes. And here's an example. So figures are similar if their corresponding angles are congruent and the ratio of the corresponding sides are proportion. So corresponding angles and sides are sides and angles that are in the same position in a different plane figure. So here, B and E are corresponding angles. Side AC and side DF are corresponding sides. And as you look here, angle A and angle D, they're congruent, meaning they're the exact same measure. So if this was 30 degrees, D would be 30 degrees. B and E are congruent angles, and angle C and angle F are congruent angles. So that fulfills this part of the definition. Corresponding angles are congruent. And then, if I look at AB and DE, if I make that a fraction of 10 over 20, that reduces to 1/2. And then side B to C and side E to F, if I put this smaller triangle over the bigger triangle again, that gives me a fraction of 6 over 12, which also reduces to 1/2. And then side AC is 7 and side DF is 14. If I put those corresponding sides as a fraction and reduce it, I also get 1/2. So that means since each side pair, each of corresponding sides reduces to the same fraction, that means that the corresponding sides are in proportion. So that's the definition of similar figures. When you're told that two figures are similar, you can write a similarity statement. And so this is a similarity statement, and it's included in a lot of our questions, and it can really help us out. So all it is it puts the letters that are corresponding to each other in the same order. So angle A is first. That means it would be congruent to angle P because it's also first. B and Q are in the middle, so that means angle B and angle Q would be corresponding. And angle C and angle R are both at the end, so both of those angles would be congruent. They'd be corresponding angles. And it works the same for the side. So side AB, that's the first and second letter, would be proportional to side PQ because that's the first and second letter. Side BC would be proportional to side QR because those are the second and third letters in both of the names. And then the first and third letters is A and C and P and Q, so those sides would also be proportional to each other. So sometimes these shapes are flipped, and it can be tricky to look at and know for sure which ones are congruent to which angles and which sides are proportional to which sides. And so we can use the similarity statement to help us out with that. So in this first problem, it's going to give us a bunch of information. So I find it helpful to actually draw these shapes, copy them down on paper, and then write the information they give in so I can visually see it. So don't be afraid to take that couple extra minutes that's going to take you to do that, to copy the shape down and write the information in, because then you're more likely to get the question right and have a better understanding of what's going on. So it's only going to help you. It's well worth the time. So here it gives me my similarity statement. And then it tells me that the measure of angle P is 95 degrees. So I'm going to write 95 by P. And then it tells me the angle Q is 72 degrees. And then it tells me that angle R is 221 degrees. Then it tells me that angle S is 36 degrees. And that angle T is 116 degrees. And I must know, what is the measure of angle X? So I know all of the angles of this bigger shape, and I know that they're similar. So I just need to figure out which angle over here corresponds to x, and it'll be the exact same number. So if I look, x is the fourth letter in the similarity statement, and s is the fourth letter in the similarity statement, the first part of it. So that means x and s are going to be similar, or the corresponding angles. So that means if s is 36 degrees, then x is also 36 degrees, and my answer is C. This question says if triangle ABC is similar to triangle DEF, so this is the similarity statement, they just use words instead of symbols. If the measure of angle A is 43 degrees and the measure of angle B is 96 degrees, what is the measure of angle F? So I'm going to go ahead and label that what I know. And that's that angle A is 43 degrees, B is 96 degrees, and we're looking for angle F. Well, when I look in the similarity statement, F is last and C is last, so that means F and C are going to be corresponding angles. But I don't know what C is either. So I'm going to have to solve for C. And the way that you do that is that you know there's 180 degrees total when you add the three angles of a triangle. So if I add how much I have used between these two angles and subtract it from 180, that'll give me my answer. So I'm going to take 96 plus 43, and that's 139. So then I have to subtract that from 180. And that's 41 left over. So that means C is going to be 41 degrees, which also makes F 41 degrees, and my answer is going to be B, 41 degrees. Now let's look at some problems where they give us side lengths and ask us for another side length. So this problem says, in the picture above, KLMN is similar to XYZW. So there's my similarity statement. If K is equal to 6, L2, M4, N9, and W 13.5, then what is the length of Z? So first I'm going to start off by labeling all the sides I know. And when I do that, it looks like this. Now I'm going to try to set up a proportion to solve for my missing side. So to do that, I'm going to have to match two known sides between the two of the shapes equal to a side pair that includes what I'm looking for. So here I know W in my second shape, and W is last in the similarity statement, and so is N, so that means W and N are going to be corresponding sides. So that's going to be one side of my proportion is going to be 9/13.5. I put the first shape in the top and the second shape in the bottom. That just helps me to keep it straight. And that's going to equal another side pair between the two shapes. So I'm looking for Z, and Z is the third letter, and M is the third letter. So that means Z and M are going to be corresponding side pairs. So I'm going to be working with 4 in my mystery number. So I put the first shape side on top, and then you could use Z or you could use X, whatever letter you want to solve for that bottom, that missing side that we need to know. So to solve a proportion, you cross multiply and divide. So I'm going to take 9 times Z is 9Z, and then 13.5 times 4 is 54. And then you divide both sides by 9. These 9s cancel, and I'm left with just Z. And then 54 divided by 9 is 6. And Z equals 6, which is going to make my final answer D. So the triangle above has a base of 32 inches and a height of 12 inches. What set of dimensions would produce a similar figure? So what that means is if I take 32 over 12 and I reduce that fraction, then I have to put another base over the height and reduce that fraction and see which one of those is going to reduce to the same fraction, just like I showed you in that first example. So if I take 32 over 12. That's taking the base number over the height number. So I'm just going to write that off to the side so it helps me remember. I can divide a 4 out of both of those, and that's going to reduce to 8 over 3. So then I want to try that for the ones in each of these answers and see if I can find one that's going to reduce to 8 over 3. So when I do that for each choice, it ends up looking like this. So I'm going to see what can I reduce A by. So 133 I can take a 7 out of, but that doesn't, I can't take a 7 out of 48. So I can't reduce that one at all. So my answer is not going to be A. Now with B, I can take a 3 out of each of those, and when I divide 123 by 3, that leaves me with 41, and 48 divided by 3 is 16. I can't reduce that any further. That's not the 8/3 that I'm looking for, so it can't be B. And now I'm going to look at C. I can take a 16 out of both of those numbers, and I have done these enough that I can see that's a big enough number. But if you needed to start with 4 and then realize it was another 4, that would work too. So when I take 16 out of 128, that leaves me with 8. And when I take 16 out of 48, that leaves me with 3, which is what I'm looking for. So C does reduce to that same number. So that means C is most likely going to be my answer. And since I just have D left, I'm going to go ahead and check it real quick. 32 and 48, I can divide a 4 out of both of those. And that's going to leave me with 8 over 12. And I can take another 4 out of that, and that leaves me with 2 over 3. Which 2/3 is not 8/3, so it can't be D either. So my answer is definitely C. Then you're also going to have shapes that are overlapping. So when they're overlapping, I find it useful to redraw them separately. So here's my smaller triangle, LQM, with a bottom number there, 8, and this side is 10. And then I have my bigger triangle, LPN, with the bottom here of X, and then this side, L to N, is 10 plus 5, which is 15. So that means this side here is going to be 15. And then I can just set up a proportion to solve them. So here, Q and M match with P and N, so that's going to be 8 over X equals, and then I have 10 over 15. And as I look, though, at my answers, none of those match. All of my answers have X in the numerator, which is fine. If you flip one side of the fraction and flip the other side of the fraction, that's the same proportion. It's just that they chose to write the side pairs with the bigger side over the smaller side instead of the smaller side over the bigger side, which is allowed. So now that I went ahead and looked at it as flipped version with the bigger triangle side written over the little triangle side, I see my answer here is C. Thank you for joining us today, and I hope you learned something new.